We're going to go over the problems in order of difficulty, increasing order. So the first one is event 5. Okay, I'm not going to actually solve each of them because this is really easy. So the one on the left, if you solve this, you should get x is greater than 2. Or, and then if you do the second one, you should get x is greater than 15/7. And then the last one on the right should come out to x is greater than 1/3. Basically, it was 1 point each on the tryout. Now, or means union. If you have a difficult time, draw a number line. So here's 2, here's 15/7. X is greater than 2 is like that. X is greater than 15/7 looks like that. If you put these numbers in a hat and you put these numbers in a hat, what's in the hat? That's what or is. X is greater than 2. Now, and, so now we have this, and means intersection. X is greater than 1/3, it looks like this. Right? So intersection is where they overlap. So where does this and this overlap when x is greater than 2? So yes, it's very important to know the difference between and or. Okay, the next toughest is the factoring. Okay, a lot of us bombed out on this one. Okay, the first thing you look for is to factor out the greatest common factor. I think everybody did that for 1 point. And then you get this. X cubed y minus 30x squared y squared plus 20xy cubed plus 24y to the 4th. Now, you have 5 terms. How are you going to factor that? Well, you got to obviously factor by grouping. So, how are you going to group them? Well, there's lots of different ways, but this is the way I saw it. I looked at this, I said, well, if you group the first, the third, and the fifth together, what can be factored out from the first, third, and fifth? A 6. So you get x to the 4th minus 5x squared y squared plus 4y to the 4th. And then from the second and fourth terms, I said, hey, you can factor out a negative 5xy. And what's going to be left? X squared minus 4y squared. So in order to do factor by grouping, you have to have a common factor here. But look at this thing here. This can be factored as x squared minus 4y squared times x squared plus y squared, except not, it's a minus. See how you have a common factor here and here? So that can be factored out. So if I factor out this and this, you're going to get x squared minus 4y squared, and what's going to be left? 6 times this minus 5xy, so 6x squared minus 5xy minus 6y squared. And then remember, in this event, everything has to be factored completely. So this would not be correct. So here's a difference of squares. Factor it. X plus 2y, x minus 2y. And over here, that can be factored. What is that? 3x, 2x, 3y, and 2y minus 9 plus 4. And there you go. Complete factoring. So yes, in this event, you have to be good at factor by grouping. So when you do your worksheets, you're going to be practicing factoring by grouping quite a bit. Okay, the geometry, a lot of people bombed out on this one as well. So you have a regular octagon, 1, 2, 3, 4, 5, 6, 7, 8. Now before I even begin this problem with side 2, let me just mention, to find the area of a regular octagon, what you do is you form a square around it, like that. So what you do is you find the area of the square, and then you subtract the 4 triangles around it. So since this is 2 and 2, and you got a 45, 45, 90 triangle there, that would be like root 2, root 2, root 2, 2, right? So the area of the square would be, what is the length of the side of the square? 2 plus 2 root 2 squared. And then you subtract the 4 triangles. And the area of a triangle is 1/2 base times height. Radical 2 times radical 2. So that's how you would find the area of a regular octagon. Now in this particular problem, we really didn't need to know. Well, I guess maybe, yeah. Why don't we actually compute this? So what is this going to be? 4 plus 8 root 2 plus 8 minus, this cancels that, minus 4. So what is that? 8 plus 8 root 2. Did I do that correctly? Yeah. That's the area of the entire octagon. So let's keep that on the side for now. So now let's actually do the problem. You actually got a point for that if you figured out the area. Now, what are we trying to do? We've got CG, this is CG, and BF, and they intersect at M. Find the area of quadrilateral BMGH. So find the area of this region here. Now there's lots of ways of doing it. Like some people, what they did is they made a square around it again. And then they said, okay, find the area of the entire octagon. Then subtract this trapezoid there. Subtract this triangle up here. And then subtract 1/8 of the octagon there and that triangle there. I mean, whatever works. Okay, that's not the way I did it. I guess we could do it that way if you want. What the heck? Let's do it that way. Since I think most of the people that got it correct, most of you did it that way. So 2 root 2 root 2 2 root 2 root 2 2 root 2. Okay, so the area of the entire octagon is this. Then you subtract this trapezoid here. Trapezoid, I don't know what you're going to call it. Okay, so what's the formula for area of a trapezoid? 1/2 the height times B1 plus B2. So the height of the trapezoid would be this. That's 2 plus 2 root 2. B1, that's root 2. And B2 right there is 2 plus root 2. Okay, so that's the area of the trapezoid. So that needs to be subtracted from this. And then we're going to subtract this triangle up here, which is 1/2 base times height. So the base is root 2, and the height is 2 plus root 2. Okay? And then we got to subtract this piece over here. Well, that's simply 1/8 of an octagon, right? So that's the area of the whole octagon. So the area of that is 1/8 of that, which is 1 plus root 2. And then this triangle here, which is 1/2 base times height, which is 1. So there you go. So the answer would be this, minus that, minus that, minus that. And you should get, I forget what the answer is, 3 plus 2 root 2. So you guys really need to do these problems on your own, again, so that you can get proficient in it. Okay, so for those of you in the JV events, that's it for you. And now we're going to discuss the harder events here. Unless you want to learn more. Okay, so let's, I think the log one is the next easiest one, so let's do that. Solve this equation, natural log x, log base 2 of x, equals natural log 4 times log base 2 of x to the 5th over 256. So obviously, if you have logarithms with different bases, you're going to change the base. So either you change everything to log base 2 or change everything to natural log. Take your pick. What do you guys want to do here? I'm not hearing anybody. Okay, so what I do, I like natural log. I change everything to natural log. So natural log x times natural log x over natural log 2 is equal to natural log 4 times natural log of x to the 5th over 256 all over natural log 2. Multiply both sides by natural log 2. Okay, so what do we got here? Natural log x quantity squared. I smell a quadratic equation. Equals natural log 4 times natural log x to the 5th minus natural log 256. Right? Using your properties of logarithms. And so what do we got here? Natural log x squared equals natural log 4 times 5. You can put, this is like this, so you can put the 5 in the front. 5 natural log 4 natural log x minus natural log 4 times natural log 256. So this is definitely a quadratic equation. So let's make one side 0. Okay, is this factorable? Well, if you want to let u equal to natural log x, you can, but I'm not gonna. So, well, you want to write everything in natural log 4. So, since 256 is 4 to the 4th power, right? You can put the 4 in the front, so that's like 4 natural log 4 quantity squared. That might make it easier to factor right there. It's like staring you in the face right there. So we're going to factor this like a quadratic. It has quadratic form. Natural log x, 4 ln 4 and ln 4 minus minus. Factors very nicely. So therefore, natural log x is equal to either 4 natural log 4 or natural log 4. So if you e both sides, you get x equal, and again you're going to put the 4 up as the power, e to the natural log banana is banana, so 256, e to the natural log gorilla is gorilla, ka-chung! And remember, when you have a log problem, you got to check your answer, yeah? Anytime you have a log, the argument here got to be positive, and both of them make it positive, so both of them are solutions. Okay, event 4. Polar. Z to the 4th is equal to negative 1 plus radical 3i to the 9th all over 1 minus I to the 10th. So if you're going to use the de Moivre's theorem and whatever complex roots theorem, you need to have it in polar form. So Z to the 4th, there's going to be 4 answers. Okay? So the first thing we do is change both of these into polar form. Now, the easiest way is to draw the picture. So if you have the real and the imaginary axis, so if you go negative 1 right and radical 3 up like this, how far from origin are you? 2. So that's 2, kiss, and obviously if that's a 60-degree angle, what's this one going to be there? So that's 2 pi over 3, right? So it's always going to be 30, 60, 90 or 45, 45, 90. Okay, what about this one? If this is real and imaginary, if the real part is 1, 1 right and 1 down, this, how far from origin are you? Radical 2. So radical 2, kiss. Now the angle can either be 7 pi over 4 or you can do negative pi over 4. Why don't we do negative pi over 4? It's smaller in magnitude. Okay, now we apply de Moivre's theorem. How do you raise a complex number to a power? You go 2 to the 9. And then you multiply the angle times 9. So that would be 6 pi. That's de Moivre's theorem. So root 2 to the 10th is 2 to the 5th. And then you multiply negative pi over 4 times 10. So that would be negative 5 pi over 2. And then when you divide complex numbers, you divide the r's. So that would be 2 to the 4th, which is 16. And you subtract the angles. So 6 pi plus 5 pi over 2, what is 6 pi? 12 pi over 2, 17 pi over 2. But then you want to reduce this angle to something you can work with, so you can subtract the multiple of 2 pi from that, which is what? Minus 16 pi over 2. So that would be 16 kiss pi over 2. Okay, now, the complex roots theorem. Now, some of you are writing the thing on your paper. So if z to the n is equal to r kiss theta, then z is equal to the nth root of r. Basically, it's the reverse of de Moivre's theorem. Kiss theta plus 2k pi all over n, where k is equal to 0, 1, 2, dot, 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 n minus 1. Yeah, but you really don't even need to know the formula as long as you know that the roots are going to be equally spaced apart. So what you do is so the first thing you do is you find the 4th root of 16, which is 2, and then you divide this angle by 4, pi over 8. Basically, that's when you plug in 0 for k. If you plug in 0 for k, see how theta divided by n? But once you get the first one, then to get the other 3, they're all going to be equally spaced apart. So if you have 4 answers equally spaced around 360 degrees, that means they're all going to be 90 degrees apart, or pi over 2. So to get the next answer, you simply add pi over 2 or 90 degrees to this one. So which 4 pi over, that'll be 5 pi over 8. And then add another pi over 2, which is 4 pi, 9 pi over 8. And then you add another pi over 2, which is 13 pi over 8. And voila, you're done. So yes, it's very important to know that they're all going to be equally spaced apart. And the last one is calculus. Now some of us couldn't even compute the correct derivative. That would be very bad. Now again, when you have a trig function to a power, you might want to write it like that so that you can clearly see that you need to use the chain rule there. I'm going to erase this because we probably need the whole board. Alright, so the first, we have to find absolute max, absolute minimum on this interval here. Okay, so remember, once you have an interval like this, you need to check the endpoints. So first step, take the derivative. So 12 box squared times the derivative of box plus 9 box squared times the derivative of box, which is cosine x. There, that is the correct first derivative. Factor out a 3 cosine x sine x, and then what's going to be left? Negative 4 cosine x plus 3 sine x. Okay, good enough. Now, to get your critical points, it's going to be when the derivative is either 0 or it doesn't exist. Okay, and then you put them on a number line to do the first derivative test. So what makes this 0 on this interval? Obviously pi over 2. What about that? 0. And now what makes this 0? Well, when 4 cosine x equals 3 sine x, or 4/3 equals tangent x, so therefore tan inverse 4/3, which is closer to pi over 2, yeah? Okay, now, if we test, well, what's a good angle to plug in over here? Maybe like pi over 4? Okay, so if you plug in pi over 4, because this is bigger than 45 degrees, right? So pi over 4. So but that's positive, that's positive. Now what about this? 1 over root 2, so you got negative 4 over root 2 plus 3 over root 2. That's definitely negative, so that's negative. And then if you plug in a number here, like tan inverse 5/3 or something tan inverse 2, you're going to get plus. So that means f is decreasing, f is increasing there. So you can clearly see that right there is your absolute minimum. So the absolute minimum value, that means the y-coordinate. So you have to take this number and plug it back into the original function, which means we need to draw a triangle. Tan inverse 4/3 looks like that. Okay, so going back into the original function, you get 4 times. Now if you look at this, I guess we can call this angle x there. No, we should, okay, we'll just call it x. What is the cosine of this angle right here? 3/5 cubed. 27/125 plus 3 times sine x cubed. We don't need to put the cube there. Look at this. What is sine? This over this. So cubing it, you would get 64 over 125. And so what is that going to be? 108 plus 192 over 125, which is 300 over 125. We divide by 25, 5, and 12. 12/5. That's your absolute minimum. Now the absolute maximum is going to occur at one of the endpoints. So we have to test both of them and see which one is bigger. So if I compute f of 0, if I plug in f of 0, here's the original function, you get 4 plus 0. And then if I plug in the other endpoint, pi over 2, you get 0 plus 3. Which one is bigger, 4 or 3? You got it. So the absolute maximum is 4. Now calculus is a very broad event, so you're gonna have to know everything. everything from differential calculus.